All right. In this homework / tutorial, I'm going to ask you to calculate R and S for each chiral center in the 3 molecules. So go ahead and pause and do that. There's 3 different molecules here. First of all, you have to determine if there's a chiral center present, and if there is, determine whether that chiral center has the absolute configuration of R or S. I'll let you pause and do that. If you want to just do the first one, let's just do the first one first. I'll do the first one, and then the second one, and then the third one. So hit pause and do the first one. Okay, are you back? Is there a chiral carbon here? How many are there? Methyl group is not going to be chiral. Remember, a chiral carbon has 4 different groups, 3 H's on that carbon. Chlorine just has 1 bond, it can't be chiral. This carbon has a CH, right? There's a CH not shown, 3 bonds to that carbon are shown. But it's got 2 methyls. So an isopropyl group, that carbon won't be chiral because the 2 methyls are identical. Leaves this carbon, it's got an isopropyl, a methyl, a chloro, and an H that's not shown. So let's put that H in. That's 4 different groups on that carbon is chiral. All right, so now you need to assign priorities. Again, you do this by atomic weight. You go 1 atom at a time. This is simply bookkeeping. You're not worried about steric size or stability or anything like that. You're just going 1 atom at a time and looking at atomic weight. So we go from this carbon to chlorine, H, carbon, carbon. Chlorine's heavier than all of those. Chlorine is priority group 1. Hydrogen is lighter than all of those. It's priority group 4. Carbon and carbon tie. So then look at what they're bonded to. The methyl's bonded to 3 H's. The isopropyl is bonded, carbon is bonded to an H and 2 C's. 3 H's lose to HCC, so isopropyl is going to be 2, methyl is going to be 3. All right, so once again, this chiral center is set up to be the easiest one to determine because the H, the low priority group, is already away from you. So all you need to do is draw your circle from 1 to 2 to 3. That circle is going counterclockwise. A low priority group is away from you. Therefore, that chiral center is S. Okay? So if I had screwed up, if I had gotten the assignment of priorities wrong here and said methyl is 2 and isopropyl is 3, I would have gone clockwise. I'd have been wrong. Likewise, if I had screwed up and had the low priority group out at us, drawn a clockwise circle and said, that it's clockwise so it's S, or counterclockwise so it's S, I'd be wrong. If I'd mistranscribed these, had the low priority group out at you, 2 errors, I would have been right. Anyway, hope you got S for the first one. I'm going to erase that and move on to the second one. So go ahead and hit pause. Figure out the absolute configuration of any chiral centers in this middle molecule, and then come back and I'll take you through it. Okay? So once again, chiral centers. Methyl is not chiral. There are 3 hydrogens in that carbon. Methyl is not chiral. 3 hydrogens. Just get used to methyl groups are not chiral. Okay, what about the middle? What about oxygen? Can an oxygen be chiral? No. A neutral oxygen is going to have 2 lone pairs. Can't be chiral. 2 identical groups on that. All right, so this middle carbon then has a methyl, an OH, an O-methyl, and an H. Those are 4 different groups. It's got oxygen, 2 oxygens, but the oxygens are not the same. So it's got a hydrogen coming out at us. Why did I draw that in black? All right, so the hydrogen is coming out at us. So now you need to assign priority. Hydrogen, 2 oxygens and carbon. Hydrogen is lighter, so it's 4. So the low priority group is coming out at us. Carbon is lighter than either of the oxygens, so it's going to be 3. All right, 2 oxygens now. What do you do about that? Well, you go to the next atom. So this oxygen is bonded to a C. This oxygen is bonded to an H. The next atom past the oxygens is where you go to look. There's a difference. C beats H, so this group is 1, and the OH is 2. Okay, now you can try to redraw the molecule, and I'm actually going to do that. So there's a quicker way, a way I use, and a way I think most people use, but you can just pick the molecule up and turn it over. And now I'm not going to draw, well, I will. So if I pick this up and turn it over, the OH will be over here, the methyl will be the OH will come to the left, the OH comes to the left, the methyl goes to the right. That O-methyl swings out at us, and the hydrogen goes to the back. Okay, and again, put your priorities in. Priorities will stay the same, you've already calculated those. And draw your arrow, 1 to 2 to 3. That's a counterclockwise arrow, so that should be S. Look at what happens on the right if we just draw the arrow. So O-methyl, 1 to 2 to 3, that's a clockwise arrow with a low priority group out. And so what I think you can do is simply draw your arrow 1 to 2 to 3 with the low priority group sticking out at you, and then take the reverse. So clockwise arrow, but you're doing it backwards. So clockwise actually means counterclockwise, which would mean that's S. You want to be really careful, if you want to redraw the structure, you want to be really careful that you just move the whole thing, that you don't invert anything as you're doing it. It's an easy thing to screw up. The other thing you can do is, as you invert, you can just treat these as, as priorities. So I'm going to turn this over with a 4 group in back. That would leave 1 up here. 2 will come to the right, or to the left. 3 will come to the right. So my 4 priority group is in the back, not shown. Right, 4 is back there, 1 to 2 to 3 now, counterclockwise, so it's S. Okay, that leaves one last one to do, the one on the right. So hit pause, take down this if you did it wrong, try the one over there. Okay, you're back. So again, first thing to do is determine if there's a chiral atom or not. Methyl's not chiral. That carbon has a methyl, a chlorine, a bromine, and a hydrogen, so it's chiral. Now assign priorities. Atomic weight, first point of difference. Bromine, chlorine, carbon, hydrogen. So you don't have to go very far. Bromine's heaviest, chlorine's next, carbon is third, hydrogen, as always, will be 4. If there's a hydrogen on a chiral atom, it's going to be the low priority group. Okay, now what? Well, a lot of people don't do this, okay? Are you awake? Don't do what I'm about to do. A lot of people will do 1 to 2 to 3. The problem with this is it depends how you draw these two. And in reality, this molecule, right, so the chlorine is there. I'm going to draw the bromine in red. Right, the bromine, well, right? The chlorine is sitting directly in front of the bromine. So build yourself a model if you want. That chlorine, there's nothing special about left and right here. All right? I could have just as easily drawn those two structures on the right are exactly the same. All right? All it does, all you're saying is you're just twisting it a little bit so you can draw it without making a mess of it like this. And now if you do the priorities, it goes the other way. So which one's right? And the answer is neither. Neither of these arrows. If that H is to the side, if the low priority group is to the side, you can't draw an arrow. You can do the trick of when the low priority group is straight out at you, draw an arrow and take the opposite. Or if it's straight away from you, you can draw an arrow and take that data. But if the H is to the side, these are wrong. So necessarily you have to put that H back. And since you have to move the molecule, put it back. Okay? Don't move the molecule and have it come out at you. So you've got to take this structure and move it. And again, this kind of goes back to Newman projections. I don't really care how you do this, but you have to be able to sort of manipulate the molecule. So you're basically going to draw a Newman looking down the chiral carbon priority group 4 bond. that's what I'm doing. I'm going to draw a Newman projection looking down the chiral carbon number 4 bond. And I'm going to erase this, so pause it if you want to write it down. And when I do that, so carbon in front, priority group 4 in back, as this turns, so I'm looking down that. If I'm looking there, the methyl is down, and I'm just going to write the priority group 3. Well, I'll write in the group. Sorry. All right, the chlorine is sticking out at you, so you turn it on. It's going to be over here, and that is 2. The bromine then is over here, and it's 1. All right, 1 to 2 to 3. That's a counterclockwise arrow, and so this chiral center is S. Look at that. I drew a bunch of chiral centers, 3 chiral centers, they all came up S. My lucky day. All right.